first thing you want to do is you want to make sure that you can kind of see which graph is which. The purple graph, notice that's F. And the blue one, that's G. If you're like me, you're going to spend about half of these problems just going, oh, right, the other one. So make sure you keep track of which one is which along the way there. All right, so first up, we're being asked, what is the value of f of 0? So what is f of 0?
3.
It is 3, absolutely, because f of 0 really means what is the value of f when x is 0. So we're looking along that x equals 0 line, and you notice it crosses f up here. And that's why it's 3, because my y value, which is really what f is talking about, is 3. All right, now let's go on to g. So g of negative 2. What is the value of g of negative 2?
1.
It is 1, because I go over here to negative 2, where x is negative 2, and I'm looking to see on the blue graph, because that is g, what's the value? And notice the y value there is 1. So that's why we get f of 0 equals 3 and f of negative 2 equals 1. All right, and again, we're going to be using the same picture as we go through, so don't worry, the picture's not changing, but of course the questions, those are all going to be changing. So for this next one, estimate the solution of the equation g of x equals 4. Now, if you are looking at this right now and saying there is no solution, g of x never equals 4, then we got to tweak your thinking about it a little bit. Because if g of x equals 4, what really equals 4 here?
G of 3.
Yeah, it's going to be at 3. Because it's saying that y equals 4, really. So x equals 3 gives us g of x equals 4. Another way that we could write this is we could write g of 3 equals 4. So notice that it was g of x that equaled 4. G equaled 4. That's like saying y equals 4. And so I'm looking along that line and looking to see when y is 4, where does it hit the graph? So that's how I came up with that. With that in mind, this one probably a little bit more straightforward. Estimate the solution, please, to f of x equals negative 1. All right, so if f of x equals negative 1, what does x equal? And again, you can visualize it this way. We're looking to see when does it hit that line, because it's y equals negative 1. So what do we get as an answer then? Yeah, notice there's 1 over here, and there's 1 over here. Now, this one is definitely at 4. This one on the left side, it's actually kind of hard to see. It looks like it's actually maybe just a little bit below the negative 3, just a little bit to the right. So it actually at negative 2.9. But if you say negative 3, certainly that's no problem. So it's at negative 2.9 and it's at 4. But again, notice we're using that function notation, how we're using it. Because oftentimes when we say f of x equals negative 1, people really, really want to put the negative 1 in for x. And we just got to get ourselves in the habit of looking at that correctly, making sure that we remember that it's like saying y equals negative 1. Now, function notation is a big deal. You've been saying function notation for years now, and it's going to continue to be a big deal here in calculus. One of the things that function notation does for us is it allows us to shorthand a lot of things, like saying, when does f of x equals g of x? So, take a look at that picture. When does f of x equal g of x? All right, so first of all, how many answers are we going to come up with? 2, yeah. Because we're looking to see where the two functions are equal. That basically just means where do the two functions cross? All right, now, from this point here on the left, what's the actual answer going to be from that?
Negative 2.
Negative 2, yeah. Because notice it's asking what values of x. So I'm just giving the x coordinate of that point. I'm not giving the y, I'm not giving the whole ordered pair or anything like that. So I got x equals negative 2. And what's my other solution? Yeah, the other solution's there too. So here x equals negative 2 and 2. Excellent. Now, function notation isn't the only important notation going forward. Last year especially, you learned interval notation. Well, so we're going to practice interval notation a little bit here. And this problem in particular is great leading us into the type of work you're going to be doing in calculus this year. And it can be a little bit tricky too if you don't think through the details. So, it's asking on what interval is f decreasing. Take a moment here, take like a minute, and actually think it through and question all the little details as you do so. All right, so first up, we're looking to see where f is decreasing. Visually speaking, what we're doing then is we're really taking a look at this part of the graph, because that's where we can see it decreasing. Now, the numbers there, we tend to get to those fairly quickly. What's the smallest number along that portion of the graph? 0. Okay, so we got 0 on the left end, and on the right end, what do we go up to? 4. Okay. Now, usually we're in pretty much agreement on those. But where things get really tricky here is when it comes to the round parentheses or the square brackets. And of course, those say whether we're including the ends or not. So first up, let's just talk about whether it's included or not. First up, let's look at 0 here. At x equals 0, is this graph decreasing? Well, to the left of 0, what's it doing? To the left, it's increasing. What's it doing on the right side? Decreasing. Those are different. The reason is that at 0 itself, it's flat. If we were to zoom way into that point, you'd see something that was flat. It has a slope of 0. Because of that, is it decreasing at 0? No. It's decreasing to the right of 0, though, which is why we still use 0 as our number. But in order to say that it's not included, we use that round parenthesis. All right, now on to the other one here. What about at the other end? What about at 4? What is it doing at 4? Well, is it decreasing? Let's find out here. The important question, again, I'm going to ask the same things I asked. To the left of 4, what's it doing? It is decreasing. Okay, that's good. To the right of 4, what's it doing? Nothing. There is no graph to the right of 4. The only way we could say it's decreasing at 4 is if it were still decreasing to the right of 4. Because decreasing means it's going from something to something. It's not going to anything here. And so at 4, it is no longer decreasing. But to the left of it, it is. And so 4 is not included again. So both of those are the round parentheses. This problem right here really is kind of the big intro to calculus, because calculus is going to deal extensively with rates. Rate of change is like the big theme of calculus. And those changes of increasing and decreasing and not changing at all, and the rates of those increases and decreases and all that stuff are going to be big themes that you see along the way here. All right, so that's interval notation, good practice on that. We're going to work that into one other type of question, because there is one other thing that tends to give people a little bit of trouble, and that's domain and range. We've been seeing it for years, and it's been a headache for years. Take a moment, figure out what would the domain and range be for f. Remember, f is the purple one there. Well, the first thing you should hopefully be wondering is, which one is domain? Is that the x or the y?
X.
It is the x. Very good. Okay, so what's the smallest x value we go to?
-4.
-4. Great. What's the biggest x value we reach?
4.
+4. Great. Now the question, interval notation, is -4 included in that graph? The answer actually is yes. And so that means square bracket, because square bracket means it's included. Now how do I know it's included? Because there's not an open dot at the end. If there were an open dot at the end of that graph, that would mean not included. But since there isn't one, yes, that's going to be included there. So on the right side at +4, is that included? Yeah, so square bracket there. All right, and then for the range. Range is the same idea, except we're looking at our y values. What is the smallest y value that graph reaches? -2. What's the biggest? 3. And square or rounded? Or, in other words, brackets or parentheses? Brackets. Because it does, in fact, reach both of those values. It reaches -2 and 3. All right, we got one last question here. Can you guess what that last question is? I just asked you domain and range of F. What's the domain and range of G? Just to make sure we got that idea fully ingrained. Now go ahead and check the domain and range you found for G. A little note there. You notice I said for the range it's from 0.5 up to 4. If you were thinking maybe 0.6, that's fine. We're estimating here from the graph, but it does end up actually being up at 0.5 there.